Hello and welcome back to Module 3 of the Dallas Fire Rescue Driver Training Program. This is the second part in our 4-part series covering pump operations. This presentation will cover the physical elements of the fire pump and the appliances used during pump operations. Upon completion of this presentation, the driver engineer should know and understand the important parts of the fire pump used by Dallas Fire Rescue, the basic functions of the fire pump and how it operates, the different parts of the pump panel, the various tools and appliances that are important to pump operations and how they are utilized. It is important to have a good understanding of how something works to efficiently and effectively operate it. The fire pump is the heart of fireground operations. Without it, we would be reduced to the old times of having to carry our water by bucket brigades to extinguish fires. It supplies the water we need to protect life and property while remaining an aggressive interior fire attack department. We will begin our discussion with looking at the physical components of the fire pump and how they operate together to provide water to our hose lines. NFPA 1901, the Standard of Automotive Fire Apparatus, has designated that if a fire pump is rated at 3,000 GPM or less, it is required to deliver 100% of its rated capacity while operating at 150 psi. This acceptance test is performed while drafting at 10 feet of elevation from a static water source. It is also a minimum standard that the pump must achieve and does not mean that this is the exact gallonage that the pump will provide at 150. If given ample volume and pressure from the municipal water supply, it is very easy for the pump to exceed the pump rating and provide greater quantities of water to fireground operations. However, once the pump has reached the maximum capacity it is able to provide, based on the water source and pump efficiency, only pressure will continue to increase after 150 psi. The current model of fire pump that Dallas Fire Rescue uses is the Endurance 2 two-stage fire pump, also listed as the CMU C20. While every part of the pump is critical to its effective operation, there are a few key components that the driver needs to understand where they are located and how they operate. First is the transmission and pneumatic shift. This is where the pump transitions from road mode to pump mode. It is a pneumatic shift that is operated by an electric controller. There is a collar that transitions across the drive shaft, which engages with either the rear shaft or the pump drive sprocket. When in road mode, the collar will contact the rear half of the drive shaft and the rear shaft, allowing the vehicle to drive. When transitioned to pump mode, the collar will disengage from the rear shaft and shift forward to engage with the hub of the pump drive sprocket. This disengages the apparatus's ability to drive and transfers power to the pump itself. Next are the water intakes. There is a single 5-inch inlet and 3-inch inlet on both sides of the pump. There is also an intake valve at the top of the pump located near the midline of the pump that receives water from the apparatus water tank. Just as the pump is the heart of the fireground operation, the impeller is the heart of the pump. Located at the center of the pump, the impellers provide the pressure we need to move water throughout the system. Each impeller within a pump is referred to as a stage. When you look at the impeller removed from the pump, there is a large circular opening in the center, which is known as the eye of the impeller. This is where water enters the impeller to be pressurized. The thin blades of metal that fan out inside the impeller are known as the vanes. As the impeller rotates, the vanes move the water through the impeller. As the water is increased in velocity and pushed out of the impeller, it is channeled into the volute. This provides a pathway for the pressurized water to be transported to the discharge valve of the pump. The 3.5-inch discharge valve is located at the top of the pump above the intakes. Now that we have covered the key components of the pump, we will now look at how water is moved through the pump during pump operations. Centrifugal pumps have long been utilized in the fire service due to their efficiency and capabilities of operating at a wide range of volumes and pressures. There are no valves within the pump itself from the point of intake through the discharge valve. Because of this, water can move freely throughout the pump when the impellers are not in motion. However, when the impeller is in motion, water is drawn through the intake and forced out through the discharge. There are two primary types of centrifugal pumps based on the number of impellers housed in the pump: single-stage and multi-stage pumps. In the single-stage pump, there is only one impeller that provides pressure, Therefore, it does not offer the ability to transition between pressure and volume mode. The single-stage pump offers the most basic example of how a centrifugal pump operates. As water enters the intake, it is channeled down the parallel piping to both sides of the pump. Water then enters the impeller shaft assembly through the eye of the impeller. As the impeller spins, it accelerates the movement of water between the vanes and discharges water outward into the collection area referred to as the volute. As the pressure within the pump increases and more water is displaced, the water is discharged into the header, where piping and valves deliver water to the discharge. The CM pump utilizes two impellers rotating on the same shaft in the same direction at the same RPM. They work independently in the volume mode to flow the maximum capacity at rated pressure. The impellers work together in the pressure mode to utilize the centrifugal impeller's ability to add pressure to the pressure being delivered from one impeller to the next. Water flow enters the intake fitting, splitting in the intake adapter. In volume, water enters the first and second stage impellers simultaneously. The rotating impellers increase the velocity of the water to produce pressure. The flow from the first stage impeller is routed through the patented Waterist ball-style transfer valve to the discharge manifold. The same flow and pressure from the second stage is routed directly to the manifold, where it combines with the flow from the first stage for maximum flow. In volume, the impellers work independently to produce maximum flow. Moving the transfer valve to the pressure mode rotates the valve to direct the increased flow and pressure to the eye area of the second stage impeller. The increased pressure forces the flap valves closed. Flow and pressure will be forced into the second stage impeller, where the impeller will increase the velocity again, thus increasing the pressure on the discharge of the pump. The pressure will be increased while operating at the same RPM as it was in volume.